Hello and welcome to your algebra recording for the week of February 6th. We are also working in the week 5 folder this week. As always, please make sure you've got your math notebook out. Remember, you do need to take notes and submit your notes in the week 5 notes assignment. So please make sure you're taking notes while you're watching this recording. You will need to submit those to get full credit for your weekly notes. And in your notes, I would like for you to start with the warm-up question. So what I would like for you to do is you're going to try these on your own. So you're going to click pause and try these 2 warm-up questions in your math notebook, and then when you're ready to check your work with mine, you'll click play. So there's 2 different questions. The first one is going to take a look at this parabola. Remember, parabola is just a fancy word for the graph of a quadratic equation. So I've got a parabola over here on the right, and I want you to find the zeros of that parabola. So this is some review from last week. And then I want you to take a look. Whoops, I got to add something here. The 2, the exponent. This is a quadratic, right? Because its highest degree is a 2. So this makes this function a quadratic function. So I would like for you to solve for this quadratic function. Find the zeros by factoring. So go ahead and click pause and try these on your own. And then when you're ready to check your work with mine, go ahead and click play. All right. So when we find zeros of a parabola, a quadratic that's already graphed, it's pretty easy. All we're looking for is where our graph crosses the x-axis, and that's going to tell us what our zeros are. So we're only looking for the x-axis. We're not looking where it crosses the y-axis, just the x-axis. So the zeros would then be x equals 1. That's going to give us a 0 because it crosses the x-axis there. And then the other 0 would be x equals 3. So those are our 2 zeros at x equals 1 and x equals 3. Right here and right there. Second one, add that square there, back there. So we need to solve by factoring. So we're looking for factors of 6 that add up to our middle term of 5. So what are some factors of 6? I know 4 and 1, or I'm sorry, not 4 and 1. I was going to say 6 and 1, but those don't add up to equal 5. How about 3 and 2? I'm thinking here. 3 times 2 is 6. 3 plus 2 is 5. So they're both going to be positive. So we're going to have x plus 3 and x plus 2. That's our factored form. And then to solve by factoring, we're just going to set each of our factors equal to 0. I'm going to move this one over so that we can do that. Set it equal to 0, solve for x, subtract 3 from both sides, x equals negative 3. Set this factor equal to 0, subtract 2 from both sides, and I get x equals negative 2. So x equals negative 3 and x equals negative 2. Those are our 2 zeros because we are solving for when this equation here is equal to 0. All right, so moving on to the next slide. This week we're going to look at graphing quadratic functions. Then we're going to look at taking a quadratic function, that U-shaped parabola that we get when we graph it, and we're going to look at how we can move it. We can move, if we're on an x-axis, if we're on a coordinate plane, I mean, we can take our U-shape and we can move it horizontally, we can move it vertically, and then we can also change the width. We can make it wider or narrower. And we're going to look at how we can determine those shifts, those movements, by just looking at the equation. All right, so before we do that, let's review parts of a parabola. This is going to be very handy when it comes to graphing. So where do we find the vertex? So the vertex is always right at it's always our minimum or maximum point of our parabola. In this case, because our parabola opens down, it's the maximum value. So every parabola is going to have a vertex, and that vertex is going to represent the most minimum or maximum value. And in this case, it's the maximum value because it does open down. It's the largest point on the parabola. Then we've got the axis of symmetry, which, remember, the axis of symmetry is just that invisible line that divides our parabola in half, if you will. It's a mirrored image. So this is our axis of symmetry. And let's review really quick how we can find or determine the equation that represents our axis of symmetry. One thing is just the axis of symmetry, if it's already graphed, it's pretty easy to determine what the equation would be. But if we're just working with an equation, and remember, when we write quadratic functions in standard form, the generic, just general standard form is a squared plus b, or ax squared plus bx plus c, where a, b, and c will represent numbers that we would plug into the equation. So to find the axis of symmetry, and this would be something good to write down, to find the equation, it's always going to be x equals, because it's a vertical line, and then to figure out what it equals, if we're just given the equation, we would take negative, whatever the b term is, over 2a. Whatever the a term is and whatever the b term is, so we can plug it into that equation. So write that down. That's a good review. And then our graph may have a y-intercept. Sometimes it won't, but that's going to happen where we cross our y-axis. So where we cross our y-axis is our y-intercept. And then last but not least, we've got our x-intercepts, and we talked a little bit about that in our warm-up. So these are our key parts of our parabolas: the vertex, the axis of symmetry, the y-intercept, and the x-intercepts. And knowing where these key features are, helps us create the shape or graph our quadratic function. So when we go to graph quadratic functions, we're going to look at identifying these key parts. So let's go ahead and take a look at that. So how to graph a quadratic function. So remember, there's a lot of stuff on this slide, a lot of important things. Our general form of our quadratic function is always written with the x squared term first, then the x term, and then just the constant term. So ax squared plus bx plus c. That's just in our generic form of our quadratic function. So to graph quadratic functions, we're going to identify the axis of symmetry, find the vertex, and find the y-intercept. And then we're going to find 2 points on the same side of the axis of symmetry and reflect those points. And we're going to have a bunch of points then that we can connect our points and form our U-shape quadratic function or our parabola. So there's some tricks that help us identify each of our key points. So first of all, we're going to graph this function right here. Y equals x squared minus 2x minus 3. So first of all, is our graph going to open up or down? So remember, to determine if our graph opens up or down, we always look at our x squared term and determine if it's positive or negative. And in this case, it's positive, which means that our graph is going to open up. And that's because of that x squared. So we know it's going to open up because our x is greater than 0. Then let's go ahead and find, let's start with our axis of symmetry. So to find the axis of symmetry, remember that equation will be at x equals negative b over 2a. And what is our b term? Our b term is negative 2. So here it's negative b, and our b happens to be a negative. So I have to put 2 negatives in there. So be careful of your negatives here. The formula asks for the negative b term. And since my b term happens to be negative, that is why I did a double negative there. We had a negative 2 for my b term. And then I'm going to put it all over 2 times a, and my a term happens to be 1. Do the math. I'm going to move this over. negative times a negative is a positive, so I know I've just got a positive 2 on my numerator, and then 2 times 1 is 2, 2 divided by 2 is 1. So my axis of symmetry occurs at x equals 1. So x equals 1, that's my axis of symmetry. So I'm going to put in a dashed line to show my axis of symmetry. So everything's going to mirror over this line. Now to find my vertex is going to sit somewhere on this axis of symmetry, right? The vertex always sits on your axis of symmetry. So we know the x-coordinate of my vertex, but now, right, because we found the axis of symmetry was x is equal to 1, so we know that the x-coordinate, if my point sits somewhere on this line, it has to be the same value as my axis of symmetry, my x-coordinate of my vertex. So I know that it's 1. So then I just need to find what the y-coordinate is when x equals 1. So we've got this equation of our parabola, or of our parabola. So if I just plug in x for 1 and solve for y, that's going to be what my y-coordinate is of my vertex. So let's go ahead and do that. So y equals 1 squared minus 2 times 1 minus 3. So I just simply used our equation and plugged in 1 for x, and I'm going to solve for y. So 1 squared is 1, minus 2 times 1 is 2, minus 3. Do the math. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So my y-coordinate is going to be negative 4. So that is my vertex, and we can go ahead and plot that point. 1, 2, 3, 4. There's my vertex. I've graphed that. Now I need to find the y-intercept. And my y-intercept is simply, if we have our equation written in standard form, it's our c term. It's our c term. So what's our c term in our equation? It's just negative 3. So I'm going to, where it crosses my y-axis is going to happen at negative 3. 1, 2, 3. So make sure you write down this in your notes, that the y-intercept always occurs at your c term, the constant term. And that's when it's written in standard form. It's our constant term that's not attached to a variable. Then, so that happens at x equals negative 3. And then we need to find 2 more points on the same side of the axis of symmetry, and then we'll reflect those points. So I'm going to choose points to the left of my axis of symmetry. So I'm going to choose, how about I'll plug in x equals negative 2 and x equals negative 3. So I'm going to plug in x equals negative 2 and x equals negative 3. So what I'm going to do then is I'm going to plug those values each one at a time into my quadratic function over here and get the corresponding y values. I'm going to do this on my own. I'm running out of time and I don't want the recording to go over. So what I'm going to do is I'm going to plug in negative 2 for x and find out what y is. So negative 2 squared, remember we're squaring that negative minus this minus 3. And then I'm going to do the math. So when I do the math, I get 5. So when I plugged in negative 2, my corresponding y value is 5. So that's a point. So go 1, 2, and then up 1, 2, 3, 4, 5. Plot that point. I'm going to do that again when I plug in negative 3. So the next point I did was when x equals negative 3. Note that when I'm squaring my a term, if it's negative, I have to square a negative twice, and it's going to become positive. So just make sure that you're squaring the negative. Negative times a negative is positive. Did my math, and I got 12. So my other point to plot would be at negative 3, 12, which is off my graph. It's over here. Now I can reflect all my points, 1, 2. This point here is 2, 3 away, 1, 2, 3 away from my x-axis, or my axis of symmetry. Same with this one. I can reflect that point. I can also reflect this point down here. And then I can draw in my graph. And there it is. I'm going to go on to the next slide, so if you need more time to take notes, which I would like you to do, go ahead and click pause. So I have a quadratic function up here. This is our key phrase assignment, week 5 or February 6th. Got a key quadratic function, and I want you to identify the axis of symmetry, and that's it. Have a great week, and let me know if you need any help this week.